Hey guys, this is Mr. Sal. This is just a quick lesson on unions and intersections for inequalities. We're really looking at or and statements. So please comment below about the video and like and subscribe. So a set, as it turns out, really is just a bunch of stuff. For math, it's usually just a bunch of numbers. And we've seen that already with the domain. It's a set of numbers that x could be for those square roots and fractions. Math people call this stuff elements. I mean, it sounds a lot better than saying stuff, right? Which again, math people, we're just trying to make ourselves look smarter than we are. And stuff or elements are not listed more than once. So if you see anything repeat, don't put it down more than once in a set, even though you'll be tempted to, okay? Well, we've seen that with, those are symbols for real numbers, integers, rational numbers, whole numbers, and natural numbers. You don't have to know those, but we've seen them before, hopefully. All right, so list or roster method. Yeah, we got that already, right? Just listing a bunch of stuff. Like this would be a bunch of stuff that you apparently wear that starts with S. I like the word smock. It sounds pretty cool, right? Smock. It's almost like something you would call someone that you hated. But it's something you wear, right? If you're like finger painting or something. Is that a fancy word for bib then?
Yeah. It's like a jacket.
It's like okay. Maybe sometimes I should wear one when I eat though. All right, set notation, we just saw that, right? X, such that X is something you wear that starts with S. Okay. Now again, this is usually numbers, so there'd be an inequality there instead of X is something you wear that starts with S. So an example of a set, C is a set of things you wear that starts with S. It's possible to have an empty set, which we'd have the fancy brackets. But some people like just the circle with the slash through it. That shows also that it's empty. To indicate that an element is part of a set, use the symbol, it looks like an E. I don't know if that's some kind of letter in some foreign language or not. If it's not part of the set, then we just put a slash through that symbol. So for example, 5 is an element of set G is the same as 5 is an element of set G. So one's in symbols, one's in words, kind of. And then negative 10 is not an element of set W is the same as negative 10. Again, it's just reading, that's the last part. Negative 10 is not an element of set W. Well, that brings us to the union of sets, which I believe they called disjunction in 980. Not that anyone cares. But the union of sets means that if we have two or more sets, that anything that belongs to any of the sets is part of the union. Okay? So you're forming a union of values, so it doesn't matter if it's here or there, it's part of everywhere. Okay? So that brings us to this example. So this is set S, where S is the numbers 1, 2, 3, and then it just continues that pattern 18, 19, 20. Let A and B be subsets of S. A subset is just a set of values that came from the first set. So we're really just looking at A and B here, okay? A has the values 1, 2, 5, 8, 9, 12, 20. B has the values 1, 3, 5, 7, 8, 10, 11, 16, and 19. So find the following. Okay. List the numbers or the elements in the set A union B. So we do need our nice fancy brackets. And I assume on the homework they'll want these listed in order from least to greatest. So I see 1 is part of both sets, but again, I'm not listing it twice. Then there's a 2, a 3. I don't see a 4, but a 5 is good. 7, the 8's, 9, 10, 11, 12, 16, 19, 20. Do you guys see any values I missed there? All right, and then I've got a closed fancy brackets. So we will see problems on the homework that have three sets though. So again, they're going to describe set S, which is just the universal set, and then we have sets A, B, and C, which came from set S. That's not completely important. You could ignore all this stuff at the beginning and just still solve the problem, all right? So don't be confused on that first stuff. But we want elements in the set for A, union B, union C, which means it has to have the values. If it's in one of the sets, then it's in the union, okay? Even if it's listed twice. So the lowest value I see is 3, then 6, 8, 9, 12, 13, 14, 15, 16, 18, 21, 23, 24, yeah, sorry, I'm having to write smaller the farther to the right I go, 26, and 30. I think I got them all. Close with the fancy brackets. Intersection of two, it doesn't have to be just two sets, you guys. But if it asks for the union of any number of sets, it's looking for any values that are part of all of the sets. Okay, so it has to be common for all of the sets, not just part of this, any of the sets. Okay, so the number that belongs to both sets or in many sets would be put in the list or the set of values that is the intersection. So again, they gave us a universal set, and that was great. But we're only really focused on that second part. We have list A, or set A, values 1, 2, 5, 8, 9, 12, and 20. And then on set B, we got 1, 3, it's a bigger set. So we want to find the intersection of these two, so it has to be part of both. Okay, yeah, it's good, yeah. 1, 5, and 8. No other values, right, that are part of both? I kind of put the 2 there. It's not supposed to be highlighted. Sorry. Hopefully that's better. So the list in the elements of set A intersection B is 1, 5, and 8. And, well, not that it's that hard just to look at the numbers, but it's still a lot less writing. So naturally on the homework we should see some with 3 sets. So we're looking for anything that is part of A, B, and C. So even if it's common between 2 of them, and it's not going to be part of this set because it needs to be the same, or it has to be in all 3 sets. So the 3s, 8s, well, I guess we can just check A. 13 doesn't work. I see 14, 3 14s. So that's going to be part of it. Is there any others, though? Ah, very good, yeah. Nice, so we got a second value. Is there a third? Nope. I don't see any other 16s, so. That's our set for A intersection B intersect C. All right, well, we have seen interval notation already, but it just shows a range of solutions for an inequality. I'm trying to think if we ever use interval notation for anything else. I don't know. It shows a range of values, right? We've seen it in domain and range as well. So graphing the solutions, for me it's helpful to graph the solutions so that I can see what the actual interval is. And of course, I guess open or close circles, or you can use parentheses or square brackets like you see there. The parentheses show that something is not included, which again we've seen, or the square brackets show that the value is included. It's like a closed circle. And yes, values can go to negative infinity as well as to positive infinity, which again is something we've seen. So I'll express this inequality using interval notation. Now again, it may help to see this on a graph, not that you have to, but I'm looking at the values 3 and 6. At 3 I've got a closed circle, and at 6 it's open. Now x in comparison to 3, it's eating the x, so it would go to the right, whereas at 6 it's not eating the x, so it goes to the left. When we see compound inequalities like we see here, then we're really looking for the intersection of the two, which is just between 3 and 6, right? Because as soon as we go anywhere like 2, then it would make this a false inequality. And if I went to the right of 6, something like 7, that also makes this false. So anything in between those two values works, which should help us, again, to make the interval. So yeah, starting at 3 going to 6, which is not included. So we have this parentheses. 3 is included, so we have the square brackets. There's our interval. So it should work the same on this one as well. We'll start with -1. Oh, it's supposed to be a 1. And this goes to 3. They're both open, but in comparison, at -1, it's eating the x, so it goes to the right. With 3, it's not eating the x, so it goes to the left, and we can see the intersection. Again, if you went to the left or the right of those open circles, you would then make the inequality false for both of them, right? Like a value like 0 makes it true for one of them, which is all we need. So that's good. That helps us to set up our interval, starting at -1. Oh man, what the heck? There we go. Going to 3. That's it. So if you ever see a compound inequality like that, but it's got more steps to it, then it may be helpful. So in 980, we just kind of worked directly with what we had. Now we may see x's in all 3 parts, which is going to make it good to separate the inequality into 2 separate inequalities. Just the middle expression stays with both, okay, which we'll see there in a moment. All right, so like this one, we'll use interval notation to express our answer. That's okay, we'll come back to that. But we need the answer first. So I'm going to separate this. First, I'm going to look at the first 2. I guess the first inequality. So that's 2x plus 3 is less than or equal to x plus 8. So that's one inequality. But again, I do have this other one with x plus 8 and 3x plus 1. So do we see how that middle expression was used in both? That's because, I mean, it is just sandwiched between them, okay? But this allows us to solve the 2 inequalities, and then hopefully the graph will help us to understand a little bit more about what is actually happening here. So I'm going to start off by subtracting 3 from both sides on this one, but I'm also going to subtract x just to save a little time. So I start out, I got x is less than or equal to 5. And then this other one, I'm going to subtract x from both sides and subtract 1 from both sides. Okay, well, that's doable still. I'm just going to divide both sides by 2. It's still not negative, so it's not going to flip the inequality. So 7/2 is less than or equal to x. I am going to graph this so I can visualize it a little bit better. 7/2 would be, we'll just say right there, and then 5 is going to be to the right of it. And the order of these will be important. If we're not sure what they are, maybe change the 7/2 into a decimal, right, 3.5. And I'm not looking for any scaling between the two, so it doesn't matter how far apart they are. I just know at 7/2 I've got a closed circle, and it's eating the x, so it goes to the right. And then with x and 5, that also will be a closed circle. It is not eating the x, so it goes to the left. So So it appears like would have whatever's between those two, okay? And my interval then starts at 7/2 and goes to 5, which also is included. All right, so this is an or statement, meaning that it just has to be part of one or the other, okay? So we need to be careful with how we look at those inequalities, or the graph anyways. So I'm comparing 5 with x and 12 with x. And at 5, what am I saying at 5? X is less than 5. All right, so at 5 I got an open circle, and it's not eating the x, so it goes to the left. On the other hand, I have x is greater than or equal to 12, so that's going to be a closed circle. And it is eating the x, so it goes to the right. So this is exactly what you're talking about, right? The interval, so just looking at the red part, it goes to negative infinity, or it starts there, and then it stops at 5, which is not included. And I'm going to unite this, starting at 12, which is included, so I got my square brackets, and this goes to infinity, which also is not included. Well, we got two inequalities here, which we need to solve. So we'll solve this first one. I'm going to add 4x to both sides and subtract 4 to both sides. Now the nice thing about solving inequalities is, again, it's like an equation, and the first part, we're always adding or subtracting, so we don't have to worry about flipping the inequality. Now that I'm dividing, though, I would want to be aware if I have any negatives. This one doesn't, so we're good. So x is less than 6 is the first part. And then we have an or statement with that. This other one, just to start out, I'll need to distribute that too. Negative 6x minus 14. All right, next up, just to simplify these, I would combine my like terms, the negative 14 and the 6. Now, same thing with that other one that we did in red there. I'm going to add 6x to both sides, so I have to add 72 to both sides as well. And then finally, we'll divide both sides by 16. So 4 is greater than or equal to x. And we have our or statement with that, so that's good to go. Solve the compound inequality, which we did, and we'll give our answer in interval notation. But again, it may help us to see this on the graph. So I've got 4, 5, and 6. At 6, I've got an open circle, not eating the x, so it goes to the left. With 4, I've got a closed circle, and it also is not eating the x, so it goes to the left as well. Now, since this was an or statement, I don't care if it intersects or not. The farthest to the left this thing goes is negative infinity. But where does it stop? It really doesn't stop at 4 because from the 6 value, right? It goes to the 6. So to make this one inequality, we would just write it like this, going from negative infinity to 6, which we would need to show, okay? I'll be careful. It seems like on tests I see that people just feel the need to separate those, okay? Or maybe you always put your x's on the left, and maybe you forget to flip the inequality at that point, okay? Because we could have written this as x is less than or equal to 4. But again, the idea would be to flip the inequality after dividing it by negative 16 in that case. Nothing new here, right? Still an or statement. Got to solve them. So first thing, I'll start with this one on the left. I'm going to distribute the 2. And then combine my like terms. Just the negative 14 and 2. And I'm going to put the x's on the right. You guys want me to put it on the left? I'm putting them on the right to make them positive, by the way. So that means I'm going to have to add 12x to both sides. And also add 28 to both sides as well. And then finally just divide by 2. So 8 is greater than or equal to x. But this is an or statement, so we should include that there. And then we got this other one. I'm going to put the x's on the left, so I'm going to have to add 2x to both sides and add 2 to both sides as well. So I've got 6x is greater than 30. I'll divide both sides by 6. And x is greater than 5. So 8 is greater than or equal to x, or x is greater than 5. Let's go ahead and look at this on the graph. So I'm looking at 5 and 8. So at 5, I've got an open circle. It's eating the x, so it goes to the right. And at 8, I've got a closed circle, which is not eating the x, so it goes to the left. Now, since this is an or statement, and we have to keep that in mind, it's just got to be part of one or the other, so it doesn't matter where the lines intersect. This goes all the way from negative infinity. It doesn't stop at 5 because of the blue line, and it doesn't stop at 8 because of the purple line. It just keeps going on forever in the positive direction, and that gives us this answer. Alright, we're solving this, but now it's an and statement, so we do need the intersection. Okay, if they don't intersect, which sometimes happens, then it just is a no solution set, which I think on the homework they want you to write DNE. So, on the equation, the inequality to the left, I'm going to add 6 to both sides. That's a 6. Then, I got to divide by 8. But I'm dividing by a positive 8, even though it's that negative 40, so it's not going to flip the inequality. X is less than negative 5. And over here, I'm going to add 7 to both sides. And now I will be dividing by negative 3, which will flip the inequality, right? So I've got x is greater than or equal to 2, which I can graph. Add negative 5 and 2. Negative 5 is open circle. It's not eating the x, so it goes to the left. And x is, it's closed circle at 2. Eating the x, so it goes to the right. So since this is an and statement, there is no intersection on this one. Okay. So this one is a does not exist problem. If this were an or statement, we would write it negative infinity to negative 5, united with 2 to infinity, which would be great, but, well, DNA may be easier to write, whatever. All right, so the and statement, again, we're looking for the intersection. We can solve this first one in 2 steps, but we're going to combine one. So I'm going to subtract 5x from both sides to get the x's to still be positive. And then I'll add 8 to both sides as well. So 3x is less than 3. Divide by 3 on both sides. X is less than 1. And we'll solve this other one. Distribute the 2. And then combine like terms. Negative 2 and 6. And it looks like I'm going to be adding 16 to both sides. 16x's to both sides. And then subtracting 64 to both sides. And well, finally, we'll divide both sides by 12. So yeah, if you did it the other way, you would have gotten x is greater than or equal to negative 5. Well, that takes us to the graph, which hopefully helps us with the interval. Negative 15 is to the left of 1, which is really all we need to know for that. And at negative 15, I got a closed circle. I don't know what the heck happened there. I apologize. Dang it. Well, now that we got that right with the negative 5, it's eating the x, so it goes to the right. And at 1, it's an open circle, though. And it's not eating the x, so it goes to the left. So even though these go farther beyond the negative 5 and the 1, we're only looking for the intersection here. So included for both is negative 5. And it goes to 1, which is only included with one of them. So it's not really included for a solution for both. So that would be the answer for our interval notation, not 15. All right, so let's go ahead and do this one as well. I'll start with the 5x plus 2 is greater than 42, subtracting 2 from both sides. And then I'll divide both sides by 5. So x is greater than 8 is my first inequality. And then we got this other one, same idea. We'll add 8 to both sides. And then now I'll divide both sides by -4, which will flip the inequality. So x is less than or equal to -2 now. This is an AND statement, so I'm just looking for the intersection on this. From -2 and 8. So I got an open circle at 8 going to the right, and at -2 I got a closed circle, but it goes to the left. So these two never intersect. So this looks like it's D and E 1.